Here we've got a gas undergoing a cycle in another piston cylinder assembly. We've got three processes that are occurring. They're going to occur in series. We're going to begin at state 1 where our pressure is 1 bar, volume is 1.5 cubic meters. And our processes, we're going to have compression with this PV equals constant relationship. We're given our internal energies for states 1 and 2, and we have the work for this process. Notice it's negative 104. Process 2 to 3, we have our work, which is 0, and then our heat transfer term here, Q, is negative 150. Finally, process 3-1, our work is a positive 50 kilojoules. We're going to ignore kinetic and potential energy. We want to find these Q values as well as U3. They both, or all three of them, need to be in kilojoules. And can this be a power cycle? So let's look at this one. So let's do part A first. And if we look for process 1, 2, we start with that one. We know delta U is going to be Q12 minus W12. Delta U was given to us right here, so we can find that with those values. We'll just have 690 minus 512 kilojoules. That equals Q12 minus the negative, gotta make sure you put that negative in there, 104 kilojoules. So with this, these plus signs or negative signs go to plus, and then you can solve for Q12. So this is going to be a positive 74 kilojoules. That means the energy due to the heat was brought into the system. Now we know that we can write for any cycle that Q is going to equal to W. And what we mean by that is your Q12 plus Q23 plus Q31 has to equal W12 plus W23 plus W31. Okay, so now we've got that. Now that we have this relationship here, we can go ahead and find Q31. Alright, so let's look at that. And we can find that because we know Q12, and then we also know Q23. So let's plug those numbers in. We're going to have 74 kilojoules minus 150 kilojoules plus Q31. That's going to equal negative 104 kilojoules plus 0 plus 50 kilojoules. That gives us a Q for process 3-1 of plus 22 kilojoules. Alright, so again, heat, our energy due to heat is coming into our system. Now that we have that, we want to find U3. So that means we're going to need to look at process 3-1. If we look at that process, look at our energy balance equation. Change in internal energy has to equal the Q term for that process minus the work term. Let's go ahead and plug in the values that we know. We know U1, because this is going to make that look like a U. We know delta U is going to be U1 minus U3. And Q31, we just found that, was 22. And then we subtract the work for that process, which was 50. U1 was given as 512 kilojoules. Now we can solve for U3. Alright, so U3 is going to be 540 kilojoules. So now we have that. And for a power cycle, remember a power cycle, you're going to use that to generate power. You can send it outside the system. So that means the W needs to be 0 for this whole cycle. That's the key thing you have to recognize with that question. So this has to be greater than 0. Now, to find that, you need to add up all of the work values for the three processes. So sum those three up and see what you get. We're going to have negative 104 plus 0 plus 50 That gives you negative 54 kilojoules. Since it's negative, it's not a power cycle. Because if it was a power cycle, this would be positive. Because that would mean work was being done by the system, not on the system. Okay, so that's how you go about working that problem.